Imagine for a moment that our home, our solar system, is a quiet, secluded island in a vast cosmic ocean. For millennia, we existed with the comfortable certainty that everything in our skies, the planets, the asteroids, the comets, were our compatriots, all born from the same primordial cloud of dust and gas billions of years ago. We believed, in a fundamental way, in our isolation. Then, in 2017, that certainty was shattered forever. A visitor entered our quiet harbour, a stranger who had journeyed from the unimaginable abyss between the stars. It was named Oumuamua, and it was unlike anything we had ever seen. It swept past us, leaving a trail of bewilderment and profound questions that still ignite fiery debates among scientists today. But that, it turns out, was just the beginning. Right now, in the year 2025, a new traveller is approaching. Its designation is 3I Atlas. It is 10 times larger than its predecessor. It is moving on an even more peculiar trajectory, and it may hold the key to unlocking the greatest mysteries of Oumuamua. The question is, are we truly ready for what it might reveal? To fully grasp the monumental significance of 3I Atlas's arrival, we must first travel back to 2017 and revisit the story of the first guest, the one that changed everything. On October 19th of that year, astronomers at the Pan-STARRS Observatory in Hawaii made a discovery that would send shockwaves through the foundations of planetary science. They detected an object moving through our solar system, but this was no ordinary space rock. Its velocity and trajectory were so extreme, so unlike anything gravitationally bound to our Sun, that there could be only one conclusion. It had come from another star system. It had crossed the colossal, silent emptiness of interstellar space to reach us. It was given the Hawaiian name Oumuamua, a word that can be translated as the first distant messenger, or more simply, the scout. Initially, astronomers cycled through the usual suspects. Perhaps it was a comet, a dirty snowball of ice and rock ejected from a distant system. Then they considered it might be an asteroid, a solid rocky body cast adrift. But the more they studied this enigmatic object, the more questions arose. Its speed was simply staggering, 87 kilometers per second relative to the Sun. To put that into perspective, for a spacecraft to achieve escape velocity and break free from the Sun's gravitational pull from Earth's orbit, it needs to reach a speed of about 42 kilometers per second. Oumuamua was travelling at more than twice that speed. This confirmed one thing for certain. This object was not from around here. It was following what astronomers call a hyperbolic trajectory, moving so fast that our Sun's gravity was powerless to capture it. It was just passing through. But this is where the story shifts from a remarkable astronomical first into one of the most profound scientific puzzles of our time. As Oumuamua swung around the Sun, passing even inside the orbit of Mercury, something completely unexpected happened. As it moved away from the Sun, it accelerated. Now, this might not sound strange at first, but think about it. When you throw a ball up in the air, Earth's gravity relentlessly slows it down, pulls it back. Similarly, when a comet or asteroid passes by the Sun, the star's immense gravity should act as a powerful brake, slowing the object down as it moves away into the cold depths of space. But Oumuamua sped up. Something was actively pushing it, giving it an extra subtle nudge of velocity that could not be explained by gravity alone. This phenomenon, known as non-gravitational acceleration, was the first layer of profound weirdness, and the mystery was just getting started. If Oumuamua were merely an inert chunk of rock, just an interstellar asteroid, its movement should have followed the predictable clockwork laws of physics and orbital mechanics. But it didn't. This meant some force, originating from within the object itself, had to be acting upon it, subtly but demonstrably changing its velocity. This single fact meant Oumuamua couldn't be just a simple rock. It had to be something more complex, something active. The mystery deepened even further when astronomers analyzed the faint, flickering light reflecting off its surface. When we observe distant objects in deep space, we're essentially looking at sunlight bouncing off them, and the behavior of this reflected light can tell us a great deal about the object's size, shape, and composition. Oumuamua broke all expectations. First, it was surprisingly bright and highly reflective, suggesting that whatever it was made of, it wasn't the typical dark, porous, carbonaceous rock we see in most asteroids in our solar system. Second, and this is where the puzzle became truly bizarre, the light wasn't constant. It fluctuated dramatically, pulsing from bright to dim and back to bright again in a regular clockwork pattern, completing one full cycle approximately every 7 hours. This rhythmic pulsing told astronomers something absolutely crucial about Oumuamua's shape. An object that is roughly spherical or even potato-shaped will reflect a relatively consistent amount of light as it spins. The only way to explain this wild variation in brightness, a change by a factor of 10, was if the object had an extremely elongated, non-spherical shape. We were seeing vastly different amounts of surface area as it rotated. The most likely explanation was that Oumuamua was extraordinarily elongated, like a cigar or a needle tumbling end over end through the void. When its long side faced our telescopes, we saw more reflected light, and it appeared bright. When its narrow end pointed toward us, the light dimmed significantly. Some scientists proposed an alternative but equally strange shape. Perhaps Oumuamua wasn't cigar-shaped, but instead resembled a disc or a pancake, incredibly wide and flat, but very thin, also tumbling as it travelled. Both of these proposed shapes are highly unusual in nature. Asteroids and comets, sculpted by eons of gentle collisions and the persistent tug of gravity, tend to be roughly spherical or lumpy, potato-like forms. Gravity pulls matter into the most compact, energetically stable shapes. Long, thin cigars or flat, wide discs are not what nature typically produces. They are, however, precisely the kinds of shapes you might expect from something artificial, something designed and built for a purpose, rather than something naturally formed through accretion and gravitational collapse. This led to the explosive question, was Oumuamua an alien spacecraft? Let's return to that critical piece of evidence, the unexplained acceleration. There is, in fact, a perfectly natural explanation for objects that accelerate as they move away from the sun. Comets do this all the time. Comets are essentially dirty snowballs, chunks of frozen gases, rock and dust, left over from the formation of a solar system. When a comet's trajectory brings it close to the intense heat of a star, its surface ice warms up and transforms directly from a solid into a gas in a process called sublimation. This outgassing creates the comet's distinctive fuzzy halo, called a coma, and its long, beautiful tails that always point away from the sun. Crucially, this outgassing also acts like a natural low-thrust rocket engine. As jets of gas erupt from the sun-facing side of the comet, they provide a gentle but persistent push, altering the comet's trajectory and velocity. This is a well-understood phenomenon, observed in countless comets. So, when Oumuamua accelerated, the most obvious, simplest, and most natural assumption was that it must be a comet experiencing outgassing. It was the Occam's razor solution. But there was one massive, glaring problem with this theory. Oumuamua showed absolutely none of the visual characteristics of a comet. There was no coma. There was no tail. There was no visible evidence of outgassing whatsoever. Astronomers pointed their most powerful telescopes, including the Hubble Space Telescope, at the object, and found no trace of the gas or dust that should have been erupting from its surface to explain its change in speed. Yet, it accelerated just like a comet would. It behaved like a comet without looking like one. It was a stealth comet, a ghost rocket pushing itself through our solar system with an invisible engine. This profound contradiction, acting like a comet but looking like an asteroid, is the core of the Oumuamua enigma. This unique combination of factors, the extreme non-natural shape, the surprisingly high reflectivity, and the non-gravitational acceleration without a visible coma led some prominent scientists, most notably Professor Avi Loeb of Harvard University, to propose a radical and controversial hypothesis that Oumuamua was not a natural object at all, but a piece of advanced alien technology. Perhaps, Loeb suggested, it was a light sail, an incredibly thin, reflective probe designed to be propelled through space by the pressure of starlight itself. This would elegantly explain its potentially flat, pancake-like shape and its acceleration without any outgassing. Or perhaps it was something else entirely, a derelict piece of alien equipment tumbling through the cosmos, or even an active probe sent to observe our system. When astronomers meticulously traced Oumuamua's trajectory backward through space, they found that it appeared to come from the direction of Vega, one of the brightest stars in our night sky. Vega, located in the constellation Lyra, has a deep and intriguing connection to human history. 14,000 years ago, due to the slow wobble of Earth's axis known as precession, Vega was our North Star, the fixed point in the celestial sphere that ancient humans used for navigation and orientation. Right now, our North Star is Polaris, but in another 12,000 years, it will be Vega again. While this alignment is almost certainly a cosmic coincidence, the object would have been nowhere near Vega when it was actually at that position in the galaxy millions of years ago. It adds a layer of beautiful poetry to the enduring mystery. As Oumuamua looped around our sun, its path also brought it relatively close to Earth. Close, of course, is a relative term in space. At its nearest approach, Oumuamua was still about 24 million kilometers away. For comparison, the Moon is only about 400,000 kilometers from Earth. So, Oumuamua was about 60 times more distant than the Moon. Still, in cosmic terms, that's a pretty close encounter. Some have speculated that if Oumuamua were an intelligent alien probe, this close pass might have been intentional, allowing the probe to observe Earth and detect the telltale signs of our technological civilization, such as our radio signals and atmospheric composition. Of course, this is pure speculation, but it's the kind of speculation that captures the imagination and underscores the profound implications of the discovery. The most frustrating part of the Oumuamua story is that we will probably never know for sure what it really was. Our astronomical survey systems are designed to find objects, but they are not fast enough to allow for rapid response missions. By the time we realized how truly strange and scientifically important this object might be, it was already hurtling out of our solar system at a blistering pace, already beyond the reach of our current technology. There have been ambitious proposals, like Project Lyra, to design a spacecraft capable of catching up with Oumuamua and studying it up close. But the object is moving so incredibly fast and has such a significant head start that any such mission would require complex gravitational assists, perhaps slingshotting a probe around Jupiter and then the Sun to build up enough speed. Such a mission would take decades to plan, build, and execute, and by then, Oumuamua would be even further away, a faint ghost in the interstellar darkness. It remains an enigma, a fleeting visitor that flashed through our lives and left us with far more questions than answers. If Oumuamua had been the only interstellar object we ever encountered, its story would have been legendary enough, a singular puzzle for generations of scientists to ponder. But then, not long after that first historic meeting with something from beyond our solar system, something completely unexpected occurred. We were visited again. In 2019, astronomers detected a second interstellar object. This one was named 2I Borisov, after Gennady Borisov, the amateur astronomer from Crimea who first spotted it. Like Oumuamua, Borisov followed a hyperbolic path, moving too fast for the Sun's gravity to hold it, and it too came from a similar region of the northern sky, this time travelling out of the constellation Cassiopeia. But unlike Oumuamua, Borisov was unmistakably a comet. It looked like a comet, it acted like a comet, and spectroscopic analysis showed it was made of the same kinds of materials: water ice, carbon monoxide, dust, as the comets we already know in our own solar system. It might not have been as mysterious as its predecessor, but its discovery was still an incredible milestone. What stands out is the sheer improbability of the timing. After centuries of meticulously watching the night sky and finding no interstellar objects at all, we had suddenly discovered two of them within the span of just 2 years. This suggested that these visitors might be far more common than we ever imagined, and our new, more powerful telescopes were finally able to see them. And then came a third. This is our newest visitor, an object officially designated 3I Atlas. The 3I signifies that it is the third interstellar object ever confirmed. It was discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, an automated telescope network designed to scan the entire sky every few nights to detect near-Earth objects that might pose a threat. The discovery was made on July 1, 2025, when the object was about 4.5 astronomical units from the Sun. An astronomical unit, or AU, is the average distance between the Earth and the Sun, our standard yardstick for distances within our solar system. At 4.5 AU, 3I Atlas was roughly 4.5 times farther from the Sun than Earth is, placing it just beyond Jupiter's orbit, but still well past Mars. What makes the discovery of 3I Atlas especially exciting and scientifically valuable is that we found it while it was still on its way into the solar system. With Oumuamua, we were caught by surprise and could only observe it as it was already leaving. With 3I Atlas, we have a front-row seat, allowing us to watch its entire journey toward the Sun in real time for the very first time. From the very beginning, what drew attention to this object was its immense size and its unusual speed, even faster than Oumuamua. But perhaps most intriguing is its approach direction. While both Oumuamua and Borisov came almost straight toward us from above the plane of the solar system, 3I Atlas is arriving from the side, on a trajectory nearly parallel to the plane of the planets, like a collision from another lane on a cosmic highway. This means that 3I Atlas likely comes from a completely different region of the galaxy, a far-away and ancient place. Our galaxy, the Milky Way, is not a homogeneous blob of stars. We usually see it depicted from above, like a top-down map, a beautiful spiral with our solar system sitting about halfway between the core and the outer edge. But if we look at it from the side, the galaxy appears as a bright central bulge surrounded by a thin, flat disk of stars, planets, and gas rotating in a spiral pattern. Most of the stars, including our Sun, are concentrated in the center of this disk, in a bustling, star-forming region called the thin disk. Above and below this lies a broader, less dense, more diffuse layer called the thick disk. Because there is little new star formation happening there, the thick disk mainly holds ancient stars and old remnants from the early days of the galaxy's formation. Beyond the thick disk are scattered ancient clusters of stars known as globular clusters. The trajectory of 3I Atlas strongly suggests that it has come from this thick disk. If that is true, this object could be incredibly old, possibly more than 7 billion years old, significantly older than our own 4.5 billion-year-old solar system. This antiquity alone makes 3I Atlas a fascinating time capsule from the early universe. But there are two more features that make it even more remarkable. The first is its sheer size. Observations from telescopes confirm that the object is surrounded by a cloud of gas and dust known as a coma, which shows that it isn't a solid rock like Oumuamua was thought to be, but a comet similar in nature to Borisov. However, the scale is vastly different. The coma of 3I Atlas measures around 20 kilometers wide, while the solid, icy core at its center is estimated to be about 11 kilometers across. That makes it roughly 10 times larger than Oumuamua was estimated to be, and about 5 times larger than Borisov. It seems that our interstellar visitors are becoming increasingly massive. The second remarkable detail is its specific path through space. Because 3I Atlas is coming from the side, it will pass by several planets as it moves through our solar system. Its closest encounter will be with Mars, coming within about 28 million kilometers. Then it will pass near Venus, about 97 million kilometers away. As it exits our solar system, 3I Atlas will sweep past Jupiter at a distance of about 53 million kilometers. In a sense, it is taking a brief but comprehensive tour through our planetary neighborhood. However, in a quirk of cosmic timing, 3I Atlas will miss Earth completely. When it travels through the inner solar system, our planet will be on the opposite side of the Sun. Because of that, our ground-based telescopes will lose sight of it around October, as it becomes lost in the Sun's glare, and we won't see it again until December, by which time it will have already passed its closest point to the Sun and begun its long journey back into deep space. As with the strange behaviour of Oumuamua, some have speculated that 3I Atlas might be more than just a giant ancient comet. Could it be an alien probe moving intentionally, observing our planets while strategically using the Sun to keep itself hidden from the one inhabited planet? With an open mind, that idea seems unlikely. It would be hard to imagine a probe travelling for billions of years across interstellar space, finally arriving at a solar system filled with life, and then deliberately avoiding that planet at the last moment. The truly exciting thing about 3I Atlas is that we still have time to watch it draw closer. In the coming months, the mysteries surrounding it will start turning into real answers, and unlike with Oumuamua, we might actually get a closer look. We probably can't launch a new spacecraft in time, but existing probes currently orbiting Mars and Jupiter could help. One Mars orbiter might be able to adjust its path slightly to get a better view as Atlas flies by. There's even a slim, ambitious chance that the Juno spacecraft currently orbiting Jupiter could be redirected for an intercept mission next spring. It's a long shot, but if it worked, we would finally see what one of these ancient visitors truly is up close. Even without a dedicated probe, scientists already have stronger theories to test. If Oumuamua wasn't an alien ship, some leading models suggest it might have been a nitrogen iceberg, a fragment from a planet like Pluto in another solar system, blasted into space by a cataclysmic collision. As it neared a star, the frozen nitrogen would vaporize invisibly, creating the mysterious thrust that pushed it in strange directions, exactly what we saw. So maybe Oumuamua wasn't built, maybe it was broken off, a piece of a distant, shattered world. That's why 3I Atlas is such a monumental deal. Every single observation helps us peel back more of the universe's great mystery and see cosmic forces in action on a scale beyond anything we've ever known. Over the coming months, as this colossal, ancient object swings around our Sun and begins its journey back into the interstellar night, we will gather more data than we ever could with Oumuamua. We will measure its composition with unprecedented precision, track its trajectory for any signs of the same strange acceleration, and search for any anomalies that might finally explain the mysteries of its predecessor. What do you think? Is 3I Atlas just a weird, giant space rock from the dawn of the galaxy? Or could it, and by extension Oumuamua, be something more? The answers are coming, and they promise to be fascinating.